Hello everyone, I'm Ms. Nilanjana Ghosh from Azan Bin Qais International School. Today's lesson is on acid-base equilibrium constant which has a symbol Ka and Kb. Chapter 8, Quantitative Equilibria. Learning objectives 8.1e. Write the expression of Ka and Kb, then work out their units. F. Work out the values of Ka and Kb for weak acids and weak bases, respectively. I. Work out the value of pKa and discuss the relationship between Ka and pKa. Let's recall some definitions which are needed for today's lesson. The first definition that we're going to discuss is acid. Acids are proton or H+ donors. Let's look at some dissociation reaction of acids. HCl dissociates to give H+ ions and Cl- ions. H2SO4 sulfuric acid dissociates to give H+ ions and HSO4- ions. Ethanoic acid dissociates to give H+ ions and ethanoate ions. Now in all these cases we see they give out protons or they donate protons. Acids can be classified as strong acids and weak acids. Strong acid. A strong acid is one which dissociates completely in water. Examples of strong acids are HCl, HNO3, H2SO4. HCl dissociates completely to give H+ ions and Cl- ions. Look at the arrow. It is an irreversible reaction suggesting that the dissociation is 100%. If we take the initial concentration of HCl as 1 molar, the capital M stands for moles per decimeter cube, then the amount of H+ ions formed will be also equal to 1 moles per decimeter cube, which suggests strong acids are good donors of H+ ions. Let's define a weak acid. A weak acid is one which dissociates only partially in water. It reaches an equilibrium as follows. Let's take an example. Ethanoic acid dissociates to give ethanoate ion and H+ ions. If the initial concentration of ethanoic acid is 1 molar, then we do not know how much ethanoate ion and H+ ions are formed because the dissociation is reversible. It's not 100%, but we do know that the dissociation is very small and the equilibrium lies towards the left. The weaker the acid, the further the equilibrium lies to the left. Let us now define a base. Bases are proton or H+ acceptors. Let's look at some equations. Ammonia, NH3, accepts a proton to form ammonium ion. OH- accepts a proton to form water. Bases can also be classified as a strong base or a weak base. Strong base. A strong base is one which dissociates completely in water. Example, sodium hydroxide, potassium hydroxide. Generally, hydroxides of group 1 and group 2 are strong bases. When sodium hydroxide dissociates, it dissociates completely to form sodium ion and hydroxide ions. If the initial concentration of sodium hydroxide is 0.1 moles per decimeter cube, the concentration of OH- ions formed is also 0.1 moles per decimeter cube because the dissociation is complete or 100%. A weak base. Weak base is one which dissociates partially in water. Example, ammonia. When ammonia reacts with water, the water acts as an acid. It donates a proton to ammonia to form ammonium ion and OH minus ions. If the initial concentration of ammonia is 0.1 moles per decimeter cube, we do not know the concentration of ammonium or the hydroxide ions because the dissociation is partial. Let us now define acid equilibrium or dissociation constant. It has a symbol Ka. Let HA be a weak acid, so HA will dissociate partially in water to form H plus ions and A minus ions. The equilibrium constant in this case, called acid dissociation constant Ka, is equal to the concentration of the products divided by the concentration of the reactants, which is equal to concentration of H plus ions times concentration of A minus ions divided by concentration of HA. Units. Since these are all concentration terms, so each of them has a unit moles per decimeter cube. So the numerator, there are two concentration terms, so moles per decimeter cube times moles per decimeter cube divided by moles per decimeter cube. If we cancel one of the moles per decimeter cube, the unit becomes only moles per decimeter cube. Some important points on Ka. Ka is called acid dissociation constant. Its unit is moles per decimeter cube. K indicates the extent that an acid dissociates into ions. It depends on temperature. Greater the value of Ka, stronger is the acid. Weak acids have small Ka and strong acids have large Ka values. Stronger the acid, the higher the Ka and the lower the pK value, where P stands for negative logarithm of Ka. And weaker the acid, the lower the Ka and the higher the pK. The relationship between K and pK is pK is equal to negative log 10 Ka and Ka is equal to 10 to the power minus pKa. Let's discuss some questions. Let us look at the table below, which gives the values of Ka for some common weak acids. Which is the strongest acid in the table? Now, if we have to look at the strongest acid, we need to look at the which has the highest Ka, and according to the table, the highest Ka value is of sulfurous acid, which has a Ka of 1.3 to 10 to the power minus 2. So the strongest acid in the table is sulfurous acid. Which is the weakest acid? If we have to find the weakest acid, we have to find an acid which has the lowest Ka, and in the table, the lowest Ka is of hydrocyanic acid, which has a Ka value of 4.9 to 10 to the power minus 10. Explain your answer. Sulfurous acid has the highest Ka and hydrocyanic acid has the lowest Ka. Calculate the pK of benzoic acid. Let's look at benzoic acid. Benzoic acid has a Ka value of 6.3 into 10 to the power minus 5. We know pK is equal to minus log Ka. So substituting the value of Ka from the table, we get pK of benzoic acid is 4.20. Please remember to use the bracket when you're calculating negative log. Next question. Propanoic acid has a pK of 4.87. Calculate Ka. We know the formula of Ka is equal to 10 to the power minus pKa. So, substituting the value of pKa in the expression, we get 1.35 into 10 to the power minus 5 moles per decimeter cube. You need to know pK has no units, whereas Ka has a unit, moles per decimeter cube. Let us now discuss base dissociation constant Kb. Kb is a measure of strength of a base. Let B be a weak base. When B reacts with water, water acts as an acid and donates a proton to the base B. So it forms BH plus OH minus. The equilibrium constant in this case, we call the base dissociation constant Kb, is given by the concentration of the products divided by the concentration of the reactants, which is equal to concentration of BH plus times concentration of OH minus divided by the concentration of the base B. Water is not included in the Kb expression because concentration of water is constant. Units. The numerator has two concentration terms, which is moles per decimeter cube times moles per decimeter cube divided by another moles per decimeter cube. If we cancel one of them, we'll remain with moles per decimeter cube. Some important points on Kb. Kb is called the base dissociation constant. It has the unit moles per decimeter cube. Kb indicates the extent that a base dissociates into ions. It depends on temperature. Greater the value of Kb, stronger is the base. Example, strong base like sodium hydroxide has a very high Kb. Stronger is the base, the higher is the Kb value and lower is the pKb. The weaker is the base, the lower the Kb value and the higher the pKb. pKb is equal to negative log 10 Kb and Kb is equal to 10 to the power minus pKb. Let us discuss some questions. A cough suppressant extracted from herbs is a weak base with a pKb value of 5.79. Calculate the Kb. Using the formula, Kb is equal to 10 to the power minus pKb, substituting the value of pKb from the question. So Kb is equal to 10 to the power minus 5.79, which gives the answer 1.62 into 10 to the power minus 6 moles per decimeter cube. Remember, Kb has a fixed unit of moles per decimeter cube. Second question. Write the equilibrium equations and the equation for Kb for aniline. Aniline is a weak base which has a formula C6H5NH2. It has an NH2 group, which means it is basic in nature. So, when it reacts with water, the water is acting as an acid and donating the proton, which adds into the NH2 group. So, the products are C6H5, NH3 plus OH minus. The Kb expression is concentration of the products divided by concentration of the reactants. So remember, water doesn't feature in the Kb expression because the concentration of water is constant. Thank you. I hope you have enjoyed today's lesson. Bye. Have a nice day and stay safe.